Describe the antiderivatives of the function f of x equals 3x minus cosine of x. Now, the first thing to notice is this word antiderivatives is plural, meaning there's many functions, actually infinitely many functions, whose derivatives will give you 3x minus cosine of x. So just to review what we mean by an antiderivative is any function, we'll call it capital F of x. So we're looking for any function, capital F of x, such that when you do this, when you take its derivative, you get 3x minus cosine of x. All right, so what we're going to do is evaluate the indefinite integral, our notation for antiderivative, of 3x minus the cosine of x dx. So that's with respect to x. Okay, so we're taking the antiderivative of this. Now we could apply some of the rules that we've covered for antiderivatives, and we can split this up. We could say the antiderivative of 3x minus the antiderivative of cosine of x. And we could actually go one step further and bring that 3 out front. So we're looking for the antiderivative of x and the antiderivative of cosine of x. And we can apply the power rule for integration. So for this integral here, we could apply the power rule. And so the antiderivative of x would be, well, we have a 3 out front, x squared, so we add 1 to the exponent and then divide by that exponent. So x squared over 2. If we were to take the derivative of this, we would be right back at the x. And then we have a minus. And the antiderivative of cosine x is sine of x. And don't forget, in each case, there is a constant of integration. We'll call that C1 and C2. All right, well, those two constants, we could combine those into one and just call it C. And so we could clean this up a little bit, and we'll have 3x to the second power over 2 minus the sine of x plus C. And so we could always check this by taking the derivative of this and making sure you're back to where you started. Okay, that does it for this problem. I hope it was helpful.